report. What if I asked you to think of a story problem to go along with these numbers? What could these numbers represent in real life?
Each class collected 230 cans, and another class collected 343 cans, and the last class collected 692 cans. How many cans did we collect together?
She added 70 with...
Actually, I went right to the 43.
Learning computation should occur through problem solving as children figure out ways to meaningfully work with numbers.
And we added plus 100. That got us.
But it really was the 90, and we said 90 was closer to 100, and 100 is easier to count. So then it got us
12. That got us 1275. And then we took away 10, and we got 1265.
The goal of computational fluency is achieved with the flexible use of strategies that are accurate and efficient.
Instead of putting 45, I'll put 40. And instead of putting 13 and 25, I'll put 20 and 10. And then when I add them up, I got 70. And then I added the 5 and the 5 and the 3 from 13, 25 to 45. And I got 13. Then I added 70 and 13. I got 83.
Students with flexibility are able to use more than one strategy for each operation. As students demonstrate efficiency, they easily use intermediate steps and keep track of their reasoning.
That equals 70, and then I added the last 13, and that equals 83.
Accuracy is ensured when students have a clear way to record their strategies and can judge the reasonableness of their results.
Times 2 because there are 2 groups of 5, and it's faster.
Any computation problem can be solved in more than one way because mathematics involves connected ideas, not isolated rules. Having access to more than one method allows students to choose an approach that best fits the numbers in a particular problem.
And that got me to 30. 25 is close to 30, so put 30. And 45 is close to 40, put 40. And 13 is close to 15, so I put 15. You get the 50.
Students should check if each other's methods can be generalized. This means the strategy can be applied to any numbers. Students also need to consolidate their methods. This involves having a few strategies for each operation that are understood well and can be used routinely.
But she already got her answer. And where's her 5s at? Samantha, where do you think the 5s went?
Your 5s went into the 45 because you took the 5 from 25 away from 20, and 45 plus 5 is 50.
She got the 2.
Students with computational fluency flexibly choose strategies to solve problems, understand and can explain their methods, and produce accurate answers efficiently.
Ashley?
10.
10. So is there a quicker way that Amber could have added?
The last spreadsheet added 1 plus 70 equals 8, so she got 978.
So she got the same answer, but she broke her numbers apart. And what did Afzal do that was different then? Let's see if someone else can answer that part of it. Okay, now looking at Ida's strategy.
In this third grade classroom, learning computation is an active problem-solving process and a collaborative one. These students have developed strategies based on their understanding of number and operations.
We're most like each other. Okay, so talk as a group and you come up with a couple reasons. Letitia.
Before we examine the addition strategies that commonly emerge in such classrooms, take a few minutes to solve 581 plus 397 in 2 different ways.
Letitia, I know you were talking to James about why. How come Ida's strategy was more similar to Letitia's? I mean, to Saya's in your opinion?
Because Simon and Ida both broke the The 400.
As the children explain their reasoning, note the number relationships that each child uses to compute fluently.
500 plus 300 equal 800.
Okay, and stop just a second. Where did you get the 500 and the 300?
The 500 from the 100 plus 300.
Okay, so the 5 came from the hundreds place, and the 3 came from the hundreds place? Okay, so you started with the largest place, then what did you do?
80 plus 90 equal 170. And I got 80 plus 90 from the tens place.
Okay, and then what did you do?
1 plus 7 equal 8, and I got the 1 and the 7 from the ones.
Okay, so then what did you do from there? How did you get your answer?
All these answers, I put them up together, and I put 800 plus 170 plus 8 equal 978.
Okay, very nice.
My problem was 581 plus 397, but I changed the 581 to a 578 because I knew 397 plus 3 would be 400, so I took 3 away from here and got 578.
Okay,
and
stop for just a second. And why did you choose 400 or why did you choose 578? Was there a reason for choosing those numbers?
I can count by hundreds real good, 400s real good, and then I can count by 500s real good, so I added them both together and got 900, and there are 78 left, and so that equals 978.
Okay. Why did you make the change then from 397 to 400?
That was the same thing that Cassie got. I put 397 plus 500
Okay, where did that 500 come from?
the 581.
Okay.
That equals 897 plus 80. That equals 977
And then what did you do?
plus 1 equals 978.
All right, excellent.
Can you explain what you did?
I added the 3 to 397.
No.
That equals 400.
Now, why did you add the 397?
So it would be easier for me to count. And I did 400 plus 581. And that's where I got that from. Equals 981. Then I minus 3. And that equals 978.
Now, why did you take away the 3?
Because that's what I added in the beginning.
He rounded 397 up to 400, and so he added 3. And then later, Nick, you told us that you had to subtract that 3. And what Nick did is what we call compensating. Now look at both of these.
The goal is to help children develop fluency with computation, not simply to come up with lots of strategies.
With the same equation, 581 plus 397, and again, 581 plus 397. What do you see in these two strategies that is the same?
They both turned a 397 on both papers to 400.
Okay, excellent, they did. They both turned both of the 397s into 400s.
And they both subtracted 3.
Okay, did they subtract 3 from the same place though?
No.
Which one? did you
As
guys-
children talk about and discuss their reasoning, their strategies become more flexible, accurate, and efficient.
Agree on themselves or just you?
The whole group.
Okay, Ramon, CJ, you both agree? Ourselves? Yes, okay. Why do you guys? feel
Now
that-
solve 445 plus 273 using each of the common strategies. As you work through the strategies, make note of which methods best fit the numbers in the problem.
Okay, you have to take away 3? Okay. Now Sal did too? Okay, he's the same number, 3 also with Sal? Okay, all right. Let's go ahead and we're going to look at Sal's strategy and Nick's strategy and we'll see how if they do both take away 3. All right, Sal, you want to come on back up? How is 346 related to 328 or 674?
It's related to 328.
Walking around
These
at
third grade
Christmas,
students learn with and from each other as they present, discuss, and analyze strategies for subtraction.
Why? Why are they?
These strategies build on their understanding of number relationships and operations.
Jessica, what do you think? Cassie, why don't you look too? So maybe
Before we look closer at the strategies that children commonly develop, solve 674 minus 328 in two different ways.
Jessica and Cassie are the same because they both have almost the the same explanation because she used 4 and she used 4.
Okay.
Because I'm trying to get to 600.
As the children explain their reasoning, note how they look at the whole problem and draw a knowledge of number and operations.
And then I added 300
Wow. Okay, you added 300. How come you added 300?
because I can get to 674 faster.
Okay, so you wanted to get up to this number like you mentioned before, but quicker, so you added 300, okay?
And that equals 630. So I added 20 more and I got 650. Then I added 4 more and I got 654. And so I added 20 to get 674.
Okay.
And then I took the 300, the 2, the 20, the 4, and the 20.
Is that why those are all circled?
Yeah.
Okay, what did you do with those numbers?
I added them all up together in 346.
Nice job.
And I broke this number apart, and then this number stands for 300. This one number stands for 20, and this number stands for 8.
Okay.
And so I had this number left, and so I added that one to 300.
Okay, so you had this number left. What is that number?
674.
Okay, all right.
And then I minus 300, and that equals 374.
Okay.
And then I minus 20 from the 2, and that equals 354. And then I minus 8 I minus 4 instead of 8.
Okay, how come you subtracted 4 instead of 8?
Because it'll be kind of hard to come back all of 8.
Okay,
So
so,
I subtracted 4, and that equals 350.
but were you done then?
No,
Okay.
because I only subtracted 4. I was supposed to subtract 8.
Okay.
And so I subtracted another 4 from 350, and that equals 346.
What is that number?
The number is 674.
Okay, and you took 330 away from it, and what did you get as your answer?
My answer was 344, but that wasn't my final answer.
Okay, so Dustin, we added 2 here to make this an easier number to work with, a friendlier number. But why do we have to add 2 there?
Because I added 2 here, that wouldn't be fair if I didn't add the 2, because I changed it to an easier number to come by.
Okay.
That's why I have to add that 2 that I added here, because I wouldn't be done with that problem.
Okay. Well, let's see if someone else can explain that too, and maybe they have another thought about that. Why don't you pick somebody?
It was 674 take away 328. I added 2 on both ends, and then it turned up to 676. Take away 330, and that equals 346.
Okay, so how come you added 2 to both sides?
Because, like on Dustin, it wouldn't be fair.
Can you give us another example that you could show us how you would add 2 to some numbers?
5, I know that 5 and 2 equals 7, and 3 and 2 equals 5, so 7 take away 5 equals 2.
Okay.
And so does 5 take away 3.
Okay, that also equals 2? Okay, so it doesn't change your answer if you add 2 to this, like you said, you had 5 take away 3 is 2, and then if you added 2 to 5 and 2 to 3, you had a new problem, but it still gave you the same answer.
What I did is I had the 674 take away 328. So what I did is I took the 600 and the 300 and added them to.
You added
I
those two.
subtracted
Okay.
them to get 300, and then I subtracted the 700 and the 20 to get 550.
Stop there for just a second. I heard Deshaun say he subtracted the 700 and the 20, and would you agree that that's what he did? He sub-
70 and the 20.
Oh, you didn't even give me a chance. All right, the 70 and the 20. Okay.
And I subtracted the 4 and the 8. But, so what I did is like, I have $4 and I owe someone $8 and I give them my $4 and I still have 4, so it's a 4 minus. So what I did is I added 350 up together to get 350, and I subtracted 4 because it's a 4 minus and I still owe them 4. So that's how I got 346.
Very nice.
In this classroom, the students often examine and compare each other's methods.
On their own. And there's something that's probably similar about both of them, or that is similar about both of them. Let's see if we can figure out what that might be, or who has an idea of what that might be. Ramon? They both broke up their numbers. Very good. In this problem, what number or numbers did Cassie break up? Okay, so Cassie broke up 328 in this problem. And in this problem, what did Deshaun break up? Did he break up this number, that number, or both the numbers? He broke up the 600 here, and then what about this number? And he broke up the 328. So in both of these problems, in order to get their answer, they broke apart their numbers, whether they broke apart one number or both numbers to help make the problem easier. Okay, nice job, Ramon.
In all grades, students need opportunities to analyze and find relationships among strategies. This helps them refine their methods as they move toward computational fluency.
Explain what happened when you did add that 2 to 674. Why don't we go ahead and have you share yours? CJ, you want to
Now solve 583 minus 257 using each of the common strategies. As you work through the strategies, make note of which methods seem to best fit the numbers in the problem.
On both ends, and then it turned up to 676, take away 330, and that equals 346.
Okay, so how come you added 2 to both sides?
Because, like on Dustin, it wouldn't be fair.
It wouldn't be fair. Okay, what do you mean by it wouldn't be fair?
Like, if there was one cookie and